While large-scale generative models like GPT and DALL-E have revolutionized natural language processing and computer vision, speech generative models still lag behind in terms of scale and task generalization. In this video, we will look at Voicebox, a highly versatile and scalable text-guided generative model for speech, recently released by META AI. It's a very advanced model and outperforms all other speech generative models. Let's dive deeper into the model, but before we do that, please like and subscribe if you haven't already, and also let us know if you would like us to cover any other model.
So, if you give it a written text, it can be read in a variety of styles. Also, it assists in audio editing and helps in removing unwanted background noise and sounds. Presently, Voicebox can process speech in 6 languages, namely English, French, German, Polish, Spanish, and Portuguese. This capability is called cross-lingual transfer. The versatility of Voicebox is endless.
Previous research focused on curated datasets like VCTK, consisting of clean studio recordings from a limited number of speakers, resulting in limitations in synthesizing speech with diverse characteristics. Voicebox employs a text-guided speech and filling task, generating mass speech by leveraging surrounding audio and text transcripts. Voicebox was trained on more than 50,000 hours of recorded speech and transcripts from public domain audiobooks in English, French, Spanish, German, Polish, and Portuguese. Voicebox is a non-autoregressive NAR continuous normalizing flow CNF model. Similar to diffusion models, CNFs model the transformation from a simple distribution to a complex data distribution, parameterized by a neural network. More specifically, Voicebox is based upon the flow matching model, non-autoregressive generative models that can learn highly non-deterministic mapping between text and speech. It enables efficient and scalable training of CNFs via a simple vector field regression loss. In contrast to autoregressive models, Voicebox can consume context not only in the past, but also in the future. Moreover, the number of flow steps can be controlled at inference time to flexibly trade off quality and runtime efficiency. Some applications require fine-grained alignment control between speech and text. Voicebox was decoupled into 2 components, an audio model and a duration model. For the audio model, to address the stochastic nature of the distribution, particularly when it spans a large temporal range, it was parameterized with CNF model. The CNF is trained using the flow matching objective with the optimal transport path. A transformer model is then utilized to parameterize the vector field. The phone sequence embeddings, along with the sequences, are concatenated frame by frame and projected using a matrix to obtain the sequence. For the duration model, 2 solutions were used. First closely follows the audio model and models the conditional distribution. The training is performed using the masked version of the CFM loss. The second solution involves regressing the masked duration based on the context duration and the phonetic transcript. The same transformer model is used, but with only 2 input sequences instead of 3, and without using the time embedding. The model is trained using an L1 regression loss on the masked phones, where G represents the regression-based duration model.
Let's take a closer look at what it can do. Voicebox can take input text and output audio in a multitude of different voices.
The quick brown fox jumps over the lazy dog.
The quick brown fox jumps over the lazy dog.
It can also generate a stylized speech output based on text input and a short reference audio clip.
The country's lush forests and diverse ecosystems offer. The quick brown fox jumps over the lazy dog.
This could one day give virtual assistants and NPCs more natural-sounding voices. Style transfer enables transposition of vocal characteristics and background noise from a reference clip
offer ample opportunities to observe and learn about the vast
to a target audio clip with text input.
The quick brown fox jumps over the lazy dog.
The quick brown fox jumps over the lazy dog.
It can also be used to produce audio of a voice in another language.
Los frondosos bosques y los diversos ecosistemas del país. The quick brown fox jumps over the lazy dog.
Someday, this could help people communicate in a more authentic way, even across language barriers. For editing, VoiceBox can remove background noise from a clip.
Hi guys, thank you for tuning in. Today we are going to show you
By resynthesizing a specific segment.
Hi guys, thank you for tuning in. Today we are going to show you
And correct spoken words via text-to-speech, eliminating the need to re-record.
Hi everyone, thank you for tuning in. Today we are going to show you
These are just a few examples of how VoiceBox can perform across a variety of tasks.
So if you offer an audio sample for less than 2 seconds, it'll match the style of the voice to use the same for a text-to-voice generation. VoiceBox, that's trying to be more representative of how people talk in the real world. And this definitely marks an important milestone in the field of generative AI.